not too rigid. I was pumping up the tires, moved them a little bit, and you can see all the movement. So I started to investigate what is going on, and it seems like the Curse of the Cannondale caught up with this bike. Welcome back to the shrine. As you guys can see, I have a cannot fail scalpel from 2015, and this is the lower hinge joint for the swing arm. And as you can see, this is a clamp. Okay, so that's a clamp joint, and in a clamp joint there's a bolt right there, but the bolt is missing. So it's an easy fix, right? Let's just go and get a bolt and replace it. So here's a suitable M5 bolt, and we can just pop it in like this and just drive it in like so. But you see, the bolt is not going in. I'm screwing it in, but it's not catching on the thread. So what is going on here? See that? So I got a longer bolt on purpose just to show you what's going on. So I'm trying to drive the bolt in, and it's not going in. So here's a little wrench. Let's just see how deep the wrench can go in. See that? It can go in only 1/2 inches. So what is going on? The bolt shank is still in a thread here. It is embedded in a thread here, and the head of the bolt popped off, most likely from the repeated cyclic load. Again, I'm going to insert this, and you can see it goes in only about 1/2 inch and not deeper. So that's why I cannot insert the bolt only that far, and it's not catching on. So now the problem is I got to take the shank of the existing bolt out of the thread, which is not an easy task. How do I know that? Well, I've done this before. Here's a swing arm for my 2015 Cannondale trigger, and my scalpel is also a 2015 model. So this trigger failed on me. I was carving in fast corners, and I felt the rear end of the bike is just loose. And I tried to investigate first, see if the shaft here is tight. I checked some other things, everything checked out. And then as I was investigating, I found out that this clamp bolt here, you can see it's similar to the scalpel. This clamp bolt, the head, was missing. And in the same way, the end of the bolt, the shank, was broken into the aluminum housing here. So this end part here is aluminum, and so this is also aluminum. The rest of the bike is carbon, so the carbon and the aluminum are bonded together here in the center, but this end is aluminum. So what I had to do is drill this out, and that's what I did. So here's a picture how I mounted it on the mill. You can see I used the plate to mount it on the edge of the mill table. And so then I can come in from the top and make sure that this hole is perpendicular. You know, it's parallel to the mill axis. And then I can come in, drill, and then use a bolt remover to remove the shank of the bolt from this hole. So I did all that, put it back together, and then I realized that the other side is cracked. You can see a big crack here in a carbon. So this bike has been apart for about 2 years, because Cannondale told me that they can help me with this, like so. They can help me a lot. And I wasn't able to purchase a swing arm from them. I was trying to find one online on eBay or Pink Bike or somewhere else. And then as I was looking, I found all these threads. So it looks like this is not a unique situation for me. This happened to other people. As you can see, here is one that has the frame cracked in the same way. Here's another one where the aluminum frame cracked. And so I think it's happening because once this joint here is not a solid stack, so this bolt is not holding it, then this swing arm is going to be able to pivot or torsion around this joint here. And so that will put a lot of strain on this bridge here, this little bridge, and also a lot of strain on this area. Okay, there's a lot of torsional stress, and that's why these swing arms fail. So you might say, in this situation, let's just make a bushing, just pop a bushing in this hole that has a properly sized hole in the center, and then drill with a hand drill to drill out the bolt, and then use a bolt extractor to remove it. Right? We don't need to take this apart. Well, the problem is that I already went through this gauntlet once with the trigger, and the trigger sees a much harsher use. It's an all mountain bike compared to the scalpel, which the scalpel is a cross-country bike. So I decided to take apart the entire rear end, clean it properly, inspect for any cracks in the swing arm, hopefully there is none, and mount this on the mill, come in, drill out the hole, and then remove the bolt head and put it back together. So that's what we are going to do today. Follow me on this journey. So here's a hand drill, a 3.3mm drill. Again, this is an M5 bolt, which means that the root diameter of the thread is around 4mm. So I can use a 3.3mm drill to come in. So as you can see, I put the drill bit into the drill, and even if I have a bushing here, the bushing would align these two. Now the problem becomes that the clearance here, right there, that clearance, you can see the drill bit is going in oblique, and that's the last thing I want. Now a possible solution could be to machine an extension for the drill so that the drill comes in from this far, but that just exacerbates the problem even more. So what we're going to do is we're going to take it apart and then mount this on the mill and do it in a proper way. So here's the swing arm removed. I'm gonna go and wash and clean this area, check for any cracks or defects. We'll go from there. Here's the swing arm removed, cleaned, and I was literally looking at it under the microscope and didn't see any cracks in this area. What I saw is some rubbing here, some wear marks. It's probably the previous owner put wider tires in it. Doesn't seem to be fresh. This was all covered by dirt, so I know I didn't put wide tires in it. Otherwise, there's some scuffs, and couldn't see much. So here, if you look, you can see the bolt is still in there, still inside the hole. So what we're gonna do, mount this and drill it out. I've done that previously. I have one time's experience. But if you've been curious how much a swing arm like this weighs, here's your best chance to see it. I'm gonna turn on the weight approximation device and do a proper weigh-in according to water rules. 620 grams, 1.36 pounds, or 21.85 ounces. That's how much this weighs. Obviously there are some components here. You can see the bushing is still attached, and then we have the derailleur hanger, we have the disc brake mounting bracket feature bolts. We also have this protector here which protects the carbon frame. So they call these carbon, but they're not fully carbon. So like, I know that this part is aluminum. You can see the threads are shiny. When you put together, you better put a little grease on it, otherwise the two bolts cannot like each other. This other part, you can see this is also shiny. So this is an aluminum insert. Probably this entire part is an aluminum insert. And then here you can see this is shiny. This is also aluminum. And then this part is also aluminum. And then you can see on the ends here that this is aluminum and the threads are aluminum. I'm not sure if you thread into carbon. I think you don't thread into carbon. You put inserts into the carbon, some kind of metallic inserts, and those are threaded. So this is a composite. So it's got carbon fiber composite, but it's also composite as far as aluminum and carbon fiber. The scalpel manual is useless again. Doesn't have any information for the case when there's a broken bolt. What to do, how to mount it. 3 hours later, that's what I cobbled up. This thing just didn't want to fit on the mill table. This is my 1951 Bridgeport mill in her whole beauty. I assumed her gender, so don't give me a hard time about that. But as you can see, the saddle is completely down. The head, I cannot raise it anymore. There's no option. And the table is completely out in this way. I have a chance to pull out the head this way more, but I wanted to leave that as a last resort. I put this plate here. Okay, got a right angle plate which is bolted down to the table, and I got two bars that are bolted to that angle plate, and I have it clamped to the plate. What I did is I machined a arbor here, and the arbor, the bottom side of the arbor, matches the hole. And if I move it up and down, you know, I can find the center of the hole. I can also find the tilt, you know, how much it's tilted this way. So bolt is tightened, everything is clamped down, and now I can proceed to go in. And what we're gonna do first, we're gonna spot it with this drill. Then we're gonna go in with a 1/8 drill and drill out hopefully the core, and then we're gonna use one of these 2 screw extractors to extract the screw. So let's get down to it. There's no fanfare, there's no big reveal. The bolt did not come out in one piece. It actually broke up into small pieces, and I managed to pull it out, and then it ended up in a chip tray somewhere, so I can't even show you that. So what I'm doing here is chasing the thread. This is a helical tap. So I chased the thread and I took this one out, the good side, and I checked how many thread engagement it has. So when I fully wind it in, you can see 1, 2, 3, 4, 5, 6, 7, maybe 8. So eight thread engagements. And I did the same thing here. So if I engage this bolt lightly, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.5 thread engagements. So the thread inside is repaired and it's deep enough. I wanted to show you one more thing. I have a little prick here, little wrench that will fit in. So you can see I can put the wrench in. It goes in for about 2¼ inches, 2½ inches. So this hole inside is really deep. Here I show it to you again, so you can see that this little wrench goes into that depth. So if I superimpose it here, you can see that's where the hole ends. So it goes all the way to here. So I assume some of the debris landed in the bottom of that hole. So now that thread is repaired, it's time to put it back together. Here's the swing arm. I removed it from the fixture, and I don't know if you can hear it. That's where the bolt went. So it looks like this aluminum piece has the hole open this way. Probably it's a through hole. And as I was drilling, the drill caught up to the bolt. It engaged the bolt and it drove the bolt down, and it fall down here. So it's there for good. Probably it's not coming out ever. While I was inspecting the frame, I realized these bearings are completely crusty. This one is completely seized. It's not turning. So I'm just gonna go and replace them. It's completely seized up. It doesn't turn. Look at that. It's just a solid piece basically. And the other one too. So I'm gonna go and replace them. Just happened to have a box of bearings, same size. These are 15 millimeters ID, 25 millimeters OD. I think it's 5 millimeters wide. That's absolutely my lucky day. Just like that, 2 new bearings are installed. It begs the question though, how do these bearings cope? Looks like this one has a little weeble wobble. I'll need to look into that too. The question always, am I going to be able to find the same bolt? Obviously, there's no time to go to the store. And the answer is enter bolts. So these bolts, I use them for 3D printers, and you can see it's the same exact size, M5 by 0.8. It's the same length, it's just the color is different. And I think I'm gonna go and replace the bolt on the other side, because this might have gone through a lot of fatigue cycles. That bolt on the bad side broke at the first engaged thread, and that is a telltale sign of reverse bending fatigue. So I'm not gonna use this bolt on the right side. I'm gonna toss it and I'm gonna put a brand new one in. These are stainless, and I'm not even sure what grade this is, if it's a 8.8 or 9.8 grade or a 10.8. I doubt they use 10.8. One of the problems with these bolts is hydrogen embrittlement, which is a well-known phenomena, and the automotive industry has been fighting it, and they came up with good ways to prevent it happening, but it makes the fasteners more expensive. And if you just buy a fastener in the store, you know, you might end up with hydrogen embrittlement at high fatigue cycles. It will break on you. So I don't see any black ones here with this hat, so I'm just gonna go and use the stainless ones. So in goes the sleeve. You can see there's some wear on the sleeve, which talks about relative movement between the surfaces. I like to put these sleeves in so that the openings are matching, so that when I apply the bolt it will compress it. In the ideal world, it should go together just like that. No fuss. I saw traces of thread locker on this bolt, so I'm just gonna put some on it. And then I'm gonna put thread locker on the other side on this bolt too. Before tightening the bolts, the instruction manual says make sure that the gap on this side and this side are the same, and then tighten the clamp bolts. So the instruction manual, the user's manual says 5 Newton meters. There you go. These are the linkage arm bearings, and they completely seized, just like the pivot bearings on the bottom. So I'm gonna go and just replace them. Old bearings, new bearings. This was so lightweight. It is carbon. You can see it's carbon. You can see the inlay on both sides. I cannot emphasize enough how important it is to have a good torque wrench, especially if it's a carbon bike. You know, there's torque spec on every of the fasteners, and you tighten one of the fasteners once without a torque wrench and you break it, you've bought yourself a expensive new component. So these bolts are 5 Newton meters or 51 kilogram force centimeter. This is a cheap Harbor Freight. I think this is 20 bucks. Get yourself one if you work on bikes. I'm not going to tighten these bolts for the brakes. I'm going to tighten them up when I install the wheel. This is the derailleur hanger. I had to remove it because with this the swing arm would not fit into the Bridgeport mill. It was too long. I just couldn't fit it. It goes like that. And look at this. That's Cannondale standardization at best. See the 2 bolts? They have different heads. At least the thread size is metric 4 for both of them. These derailleur hangers are indispensable. If you have a nasty crash, you want this part to fail and not your expensive frame. This is by far the nastiest part of the bike. Gear, I cleaned it up a little bit, but it's still real dirty. Watch how they are done. See, you can put them on without removing the crank arm. On a good days, I can just do one swoop move and just put it on. Okay, it goes like that. And with that, she's ready to go again. But before I take it out for a ride, let's see if there's any extra play. You can see the rear end is solid. It's not wobbling here. There is no play. All the bolts are tightened. Everything is ready to go. So that was a successful repair. I'm really pleased with the results. Hope you guys enjoyed the
video and hope you learned something. Come back next time. See you. Bye.